Hi, Assalamualaikum and hello everyone. My name is Muhammad Syahiran bin Izham, and together with my friend Muhammad Asyraf Hakim, we will present about specific heat capacity of gases and application in heat engines. First, what is specific heat capacity? It is amount of heat required to raise the temperature of a unit mass of a substance of 1 Kelvin. For gases, we have two important values, CV, which is specific heat at constant volume, and CP, at constant pressure. For an ideal gas, Cp minus Cv, which is constant pressure minus by constant volume, equals to R, while their ratio is called gamma, where gamma equals to constant pressure over constant volume. These properties describe how gases respond when they are heated, compressed, or expanded. Now Asyraf will explain their physical meaning and role in heat engines.
Alright, now I'm going to explain the physical meaning of specific heat capacity. There are two important types of specific heat capacity for gases, which is CV and CP. Firstly, CV is the specific heat capacity at a constant volume. Since the volume doesn't change, the gas cannot expand, so no work is done. This means all the heat supply is used to increase the gas internal energy, cause its temperature to rise. The equation is QV equals to mCVT. Next, Cp is the specific heat capacity at a constant pressure. In this case, the gas is free to expand while being heated. Because the gas expands, part of heat energy is used to do expansion work, while the rest increases the temperature. Therefore, more heat is needed compared to the constant volume. The equation is CQP equals to mCPT. The ratio of these two values is called gamma, equals to Cp over Cv. This ratio describes how the gas behaves during compression and expansion, which is very important in many thermodynamic processes. Now I'm going to explain the role of specific heat capacity in heat engines. The heat engines convert heat energy into mechanical work. Example include petrol engines, diesel engines, gas turbines, and jet engines. The performance of heat engines depends on the value of CV and CP, and especially the ratio of gamma. These properties determine how the gas responds when it's compressed and expands inside the engine cylinder. As shown in the Otto cycle diagram, the gas first undergo compression, then heat is added through the combustion, followed by expansion to produce useful work, and finally heat is rejected before the cycle repeats. The thermal efficiency of ideal Otto cycle is given by eta equals to 1 minus 1 over R to the power of gamma minus 1. The higher value of gamma result in higher thermal efficiency for the same compression ratio. This means the engines can convert more heat into the useful work, improve the fuel efficiency and overall performance. That's all for me.
So, why does specific heat capacity matter? It determines how much heat is needed to change the temperature of a gas. It also affects how gases behave during compression and expansion. When a heated gas expands, it can push a piston and produce useful work. Therefore, specific heat capacity affects the performance and efficiency of an engine. Understanding these properties also helps engineers design engines that use energy more efficiently and reduce the energy losses. These properties are applied in many types of heat engines. In petrol engines, the air-fuel mixture is compressed and ignited, and the gas properties influence the engine efficiency. In diesel engines, higher compression increases the air temperature before combustion, therefore affecting both power and also the efficiency. In gas turbines, high temperature gases expand through the turbine blades to produce useful work. And in jet engines, hot gases expand at high speed to generate thrust. So although these engines operate differently way, they all depend on the thermodynamic properties of gases. In conclusion, what I can conclude is specific heat capacity is an important factor in understanding and improving heat capacity performance, heat engine performance. So I think that's all from us, me and Asyraf. So have a nice day and thank you for watching. Bye.